Hi guys, and welcome to this my video on simultaneous equations using substitution. Now over here in Australia it's part of the Year 9 course. I have no idea where it is elsewhere in the world, but solving simultaneous equations is massive. It is huge, not just the algebra behind it, but why you are doing it. Now I'm going to get into that in this video, but before I do that, can you do me a massive favor and subscribe to my YouTube channel? I know there really needs to be angels weeping in the background the number of times I ask this, but if you haven't found my channel before, and even if you have, sitting in a room talking to myself is a little bit weird at the best of times, and obviously so few people watch math videos. By subscribing, you just let me know that you're out there and you've watched the video and that actually what I'm doing is hopefully useful. If you can do that, that will be greatly appreciated. Now, I've got a website as well, maffsguru.com, where all of these videos are with downloadable notes. So everything I write on behind me, you can download, all right? And it's in a PDF form. You can use it in your summary books or just for revision purposes. There are exam questions. There are, I don't know, all of these videos and so much more. So hopefully you can head over there soon. Now, what I would normally do is go through our learning objectives, but I've pretty much said we're going to talk about simultaneous equations. The whole point of solving sets of simultaneous equations and the equations you're going to deal with are actually straight lines. We've talked about that in previous videos and it's massive later on. But the basis behind doing this is what you're really doing is you're finding where two straight lines cross. This is part of the linear course. Now, as I say here, there are lots of ways of solving simultaneous equations. And the four that I could come off my head is graphically, and that's basically by drawing the equations, by drawing them on some sort of graphics program or by hand, again, coming later on, and finding out where they cross. So here is an example of two straight lines that cross. And where they cross, we call it the solution. Yeah, so when we have things in terms of x and y's, what we're really doing is when we're finding crossing points is one solution, a point where the two lines cross. We can actually do it by by algebra, in a way called substitution, a way by elimination. That's going to be my next video I record, and something called matrices, which is really in VCE. So over here, if you're doing this in Australia, you'll do it in your VCE. Maybe in the UK, you'll do it in A-level, I don't know. But again, just remember that a point of intersection where two lines cross, it's called a solution. So let's find solutions to simultaneous equations. Now, algebra is a huge trick, massive trick. There's just lots and lots of rules that you have to follow, and the more you practice, the better you get. But one of the tricks we can employ is actually this one here. If you look at these two equations, 2x plus 3y equals 6. Please just take my word for it until a later chapter in this course that is a straight line graph. If I was to fire up desmos.com and put in 2x plus 6y equals 6, then I am basically going to get a straight line graph, right? That's beautiful. If I get 4x plus 6y equals 12, put that into Desmos, I'm going to get a straight line graph. Well, actually, I'm going to get the same straight line graph. Because one of the tricks we can employ in algebra is, what do you notice I've done to get from the top equation to the bottom equation? And I've done the same thing to every single term. I have, in fact, multiplied by 2. Now, when you do that, you're actually just playing a trick on someone. In that situation, 2x plus 3y equals 6 and 4x plus 6y equals 12 are exactly the same equation. I know they look different, but each term has been doubled and it'll be the same. Now, there are lots and lots of tricks that are about to come up. Let's see whether we can work through some questions, because that's what you're here for, isn't it? To look at some questions. Now, we are going to solve all of these questions by something called substitution. If you remember, substitution is where you take one thing off and put something in its place. Something of equal value. And again, there are tricks to all of this that I'm going to sort of hopefully get you to do as we work through this video. So, we've got the equation x plus y equals 10. That's just a straight line. But we are told on my next line that y is equal to 4x. At one point on that line, at one point where those two things cross, the y value is equal to 4 times the x value. Now, what does substitution mean? The reason we can't solve this equation at the moment is because I've got two unknowns. I've got an x value and a y value. I can't solve it, but I've got a way of being able to. Because in my next equation, it says, well, hold on. Anywhere you see a y, you can replace it with 4x's. Oh, well, hold on a moment. I can see a y here. So that means I can rewrite this equation here. So I'm going to call that equation 1. He says writing in highlighter. So let's write that as equation 1. So that's now going to become x plus, I've seen a y. Y is equal to 4x. Put the 4x is equal to 10. Now, what that's managed to allow me to do now is solve the equation. Yeah, because I've no longer got two unknowns. I've got one unknown, and by that I mean I've got an x term and an x term. I've turned all of those x's and y's into just x's. Well, I know that x plus 4x is 5x. Oh, 5x equals 10. Divide both sides by 5, and I get x is equal to 2. Now, sadly, again, a lot of people think I've finished now. You actually haven't finished. To be able to do this, you've got to solve it. You've got to find values for both x and y. So I now know that x is equal to 2. Well, how would I find my y value? Do you see? Well, they've told me here that the y value is equal to 4 times the x value. So in which case, if I know that y is equal to 4x, I know that x is equal to 2, so y would be equal to 8. Now, in this situation, because we're dealing with x's and y's, I would generally write it in terms of coordinate. We'll leave that one there for the moment because that upsets a lot of people. But then I would normally say to my kids, write that as 2, 8 as a solution to where they cross. But x equals 2, y equals 8 is okay as well.